Welcome back. In the last video, we have introduced 5 different built-in data types, learned how to define and initialize some variables using these 5 built-in data types, and then we learned how to read and write these variables in the console. Today, we will learn the way to modify the meaning of some of these built-in data types using specifiers, so that we expand them to a much larger set. Let's start. So there are 4 specifiers: long and short, signed and unsigned. Here, long and short can be used to modify the maximum and minimum values that a data type can hold, while the signed and unsigned specifier tells the compiler how to use the signed bit for the integral type and char. Before we continue, let's quickly review how an integer can be saved in memory. The fundamental unit of memory inside a computer is called a bit. So here, each small box represents 1 bit. Each bit takes the value of 0 or 1. Byte is equivalent to 8 bits. So here we have 8 small boxes, and that is exactly 1 byte. To convert this binary back, we need to assign each bit a number. The rightmost bit is assigned the number 1, which is 2 to the power of 0. The second bit from the right is assigned with the number 2, which is 2 to the power of 1, and then 2 to the power of 2, 2 to the power of 3, and so on and so forth, until 2 to the power of 7. Then we check the value of each bit. If it is 0, we skip the assigned value. If it is 1, we keep the assigned value, and then to sum them up. In our example, it is 2 plus 8 plus 2, which is 42. Here we used all 8 bits to represent a positive value. We must also consider representing the negative values, that we have to sacrifice the most significant bit, which is the leftmost bit, for the sign, and use the remaining 7 bits for the value. Here is an example. In C++, char is used to hold a character, but sometimes it can also be used to store a very small integer. No matter signed or unsigned, as we will see in our output later, char is normally stored in memory with 8 bits or 1 byte. In the memory, it should look exactly as our examples here. For the unsigned char, all 8 bits will represent the value, so in theory there will be 2 to the power of 8 or 256 different values. Hence, unsigned char can hold values from 0 to 255 inclusive. For the signed char, as we have already mentioned, the leftmost bit will be used as the sign. Only the remaining 7 bits will be used to represent values. Hence, the range will be evenly divided. That is from minus 127 to 127. We need to note that for the char, without the specifiers, on some machines it is the signed char, and on some other machines it is unsigned char. Hence, it will be quite problematic to use char as a small integer. To solve this issue, we need to make sure that signed and unsigned is specified explicitly if the char is used as a small integer. Here, we only listed the type int with the 4 specifiers. The plain int is the same as the signed int, and we can use unsigned ints if we know that the values cannot be negative. If we see short and long as data type, they are actually the same as short int and long int. In practice, the type short int is usually too small, while the type long int often has the same size as the int. So if your data value are too large and the int cannot hold your values, use long, two longs instead. For the floating point data types, you will probably see the following three here: float for the single precision, a double for the double precision, and the new data type long double is for the extended precision. In practice, float usually does not have enough precision, and most of the time we should stick to the double. The precision provided by long double is usually unnecessary, and it will bring additional runtime cost. Okay, that's all the new built-in data type we want to discuss today. To see the size of an object, we can simply use the sizeof operator with the object. Note that the return size of the operator is in byte, and if we want to see the size in bits, we need to times 8 to do the conversion. Let's click compile and run, and put the window on the left hand side. And here is a table I obtained from the CPP reference website. And we can see the signed and unsigned char is only 8 bits. It matches with the table, at least 8 bits. The size is even smaller than the short int. We can see from the table for the size of the int, it should be at least 16 bits, but on the some data model, it can be as large as 32. On my PC, the size of int will be 32. It is the same as the long int, so there's no benefit if I use long int, as the long int will have exactly the same range as the signed int. Here we also see the size of 3 floating types, and we can see the long double is pretty large with 128 bits. As we mentioned before, most of the time we should stick to the double, which is only 64 bits. That's pretty everything for the video today. Thank you for watching, and I will see you in the next one.